In this lecture, I am going to talk about the need for modulation. The term modulate means regulate. The process of regulating is modulation. Okay, so for regulation we need one physical quantity which is to be regulated and or another physical quantity which dictates regulation. For example, if you take a water tank, there is a pipe, small pipe, and you put a tap here. Okay, so the quantity which is to be regulated is water, and another quantity which regulates is a tap, okay, which regulates the flow of water. Similarly, you can take a gas cylinder, on top of that you put a regulator and you take the pipe, gas comes out. So one quantity which is to be regulated and another physical quantity which dictates regulation. So for regulation we need two quantities. One quantity it is to be regulated and another quantity which regulates or which dictates the regulation. Dictates. Regulation, and another one is to be regulated. Okay. So in electrical communication, the signal to be regulated is termed as carrier. Okay, so the quantity which is to be regulated is termed as carrier. Okay, so the signal which dictates regulation is termed as modulating signal. Modulating signal. This guy dictates and this is to be regulated. Okay, so this modulating signal is also called a message signal. Like you have acoustic pressure that is given to your microphone, and the output is an electrical signal, and this is your modulating signal. Or you can also call message signal. Okay, fine. The modulation process is the most important operation in the modern communication systems. Hence, before studying the modulation and its types, it is very important, it is very essential to know the need for modulation. Why do we need modulation? What is the purpose? If I don't do the modulation, then what are the problems that I will face? These are the typical questions that one should understand before we enter into modulation. Okay, so one can understand the need for modulation in two ways. One is by informal way and formal way. Let us understand informal way and then we'll come back to formal way. So it's very easy to understand through an example. Okay, if any new concept that you want to understand, it's better to try to understand through an example. That is much more easier. Okay, so in order to better understand the need for modulation, consider the example. Like let's say you are at Delhi. Okay, there is some live orchestra function is going on. Okay, some reputed artist is doing some cultural event. Okay, some very famous artist is organizing this at a very far distant place, let's say Mathura. Let's say around 150 kilometers, I guess, maybe something so. Now you cannot come to Mathura from Delhi by walk. It takes long time and it's not possible also. So it is too far to reach the destination city by walking. Okay, you cannot come by walk. Even if you come, it takes more time and you cannot come on time. So what you do in that case? You have to find some other transport mechanism. So you have decided to attend the event and enjoy the live performance. Then what will you do? The obvious choice is you will take the help of transportation vehicle. Let's say you hire a car. Maybe within 2 hours you can reach. Okay, the vehicle will carry you from the source city, that is from Delhi, to the destination city. Thus there are two important aspects to be observed in this example. The first one is you. Okay, you are sitting at Delhi. Okay, so this is your message. Okay, because you are the message. So you want to go and attend the function at Mathura. The second one is the transportation vehicle, which is the carrier. So you are taking the carrier car, right? That car is going to be the carrier. Once you reach the destination city, the purpose of the carrier is served. Just to get down from the carrier, car and afterwards you don't bother about the vehicle, right? So exactly similar situation is present in an electrical communication. The same kind of situation. So the message signal which is to be transmitted to the receiver is like you. Okay, so instead of you, I am having a message. You transmit for a long distance. So here you used car and here I am going to use carrier. So the carrier takes the message to a long distance. And you cannot travel for a long distance by yourself. Similarly, the message signal cannot travel for long distance by itself. Therefore, it should take the help of the carrier, which has the capacity to take the message to the receiver. So this is a basic reason why we need to do modulation, so that the message can sit on the carrier and reach the receiver. Otherwise, it cannot reach. So this is an informal way of understanding the need for modulation. Now let us talk about the formal way. Why do we need the modulation? So in a more formal way, the need for modulation can be explained as follows. Like you take voice signal. We always take the example of voice signal. Example as a voice signal. The frequency is, let's say, 4 kilohertz, highest frequency. So the distance that can be traveled by a signal in an open atmosphere is directly proportional to its frequency. So the distance that can be traveled by a signal in an open atmosphere is directly proportional to frequency. Okay, if frequency is high, then you can cover long distance. But unfortunately, no one can speak more beyond 20,000 hertz, right? That is our audio frequency range, 20 hertz to 20,000 hertz. Okay, so most of the message signals like speech and music are in the audio frequency range. This is the audio frequency range, 20 hertz to 20,000 hertz. And hence they can hardly travel for a few meters on their own. It cannot travel for long distance, maybe some 10 meters or 15 meters, that's it. Beyond that it cannot travel. So therefore the distance traveled in an open atmosphere is directly proportional to frequency or inversely proportional to its wavelength. 1 over wavelength. So therefore what we need to do is we need to increase the frequency by some other mechanism, that is called modulation process. No matter what you do, somehow you change the spectrum from one location to higher end location, so that you can make the signal to travel long distance. Okay, further for efficient radiation, this is the first point. And the second point is for efficient radiation and reception, the transmitting and receiving antennas would have to have lengths comparable to quarter wavelength. Okay, quarter wavelength means lambda by 4. We know how to calculate lambda. Lambda is equal to velocity over frequency. So the velocity in the free space is 3 times 10 to the 8 and over frequency. And you just find out the lambda wavelength, and the antenna size should be antenna length should be comparable to a quarter wavelength. This is also called quarter wavelength. Of the frequency used for a message at 1 megahertz. Let's say you take a message signal m of t and its frequency is, let's say, 1 megahertz. Then what is the wavelength? Wavelength is equal to 3 times 10 to the 8 over 10 to the 6. Then this is roughly 300 meters. Okay, lambda equal to 300 meters. So lambda over 4 equal to 75 meters. Therefore the antenna length should be about 75 meters. Alternately, for a signal at 15 kilohertz, like your m of t is at 15 kilohertz. So let us take a music signal or a voice signal. Now the antenna length is going to be lambda is equal to 3 times 10 to the 8 divided by 15 times 10 to the 3. So if you simplify this, it will be roughly 5000 meters. So a vertical antenna of this size is impracticable. It's not at all possible. Therefore, you cannot radiate the signal into the open atmosphere. So this is the second reason that we need to go for modulation. There is an even more important argument against transmitting signal frequencies directly. All message is concentrated within some range. That range is, let's say, audio frequency range 20 hertz to 20 kilohertz for speech and voice. Speech and voice one and the same. Speech and music, because music instruments can produce frequencies about 10 kilohertz also, but a human being, it's very difficult to speak beyond 10 kilohertz or beyond, in fact, 8 kilohertz. Even if there is a frequency content, but its amplitude is very little, negligibly small. Okay, maybe few megahertz for video, like as I said, 4.5 megahertz for video signal. These are typical values one should remember, so that all signals from different sources would be hopelessly and inseparably mixed up. For example, let's say person 1 is talking in the frequency range 300 hertz to 3100 hertz. Person 2 also speaking the same frequency range. That is a problem. You take another person. If all of them start to speak together, then all the signals will mix up each other, and finally you cannot separate out. Therefore, in order to separate the various signals, it is necessary to convert them all to different portions of the electromagnetic spectrum. Maybe I can shift this guy to 550 kilohertz, and this guy I will shift to 555 kilohertz, and this guy I will shift to 560 kilohertz. Now they will not overlap each other. So that is the beauty of your modulation. Now look at here, this is a spectrum occupied by the modulated signal, right? So different portions of the electromagnetic spectrum. So the person 1 occupies for 550, person 2 occupies 555, and person 3 occupies 560 kilohertz. Sorry, this is kilohertz. So each must be given its own carrier frequency location. So the first person's carrier location is 550 kilohertz, second person's carrier frequency location is 555, third person's carrier frequency location is 560 kilohertz. So this overcomes the difficulties of this also overcomes the difficulties of power radiation at low frequencies. See, there are two things in one throwing one stone and getting two mangoes. Like the first one is you are avoiding the confusion or mixing up this 3% voice, and also you are talking about in terms of 550 kilohertz, thereby you are reducing the antenna size also. That also one advantage that you are getting. So therefore this also overcomes the difficulties of power radiation at low frequencies and reduces the interference. So because of this, interference with others reduced, okay, and radiation also improved, and antenna size reduces. So three advantages that you can get it. So once signals have been translated, a tuned circuit is employed, because you recall from your oscillator circuits, you have some tuned circuits. You tune the inductor or capacitor, you can change the oscillating frequency either 550 or 555 or 560 kilohertz, like that. You can tune the carrier frequency that you employ in the front end of the receiver to make sure that the desired section of the spectrum is admitted and all unwanted ones are rejected. Anyway, that we will discuss in detail in the upcoming lectures under the topic called super heterodyne receiver. So I will not talk much about in this at present, but when I come to the demodulation part, that time I will talk about super heterodyne receiver. There we will use tuned circuits in order to allow a particular desired section of the spectrum and remove unwanted ones or reject unwanted ones. So the tuning of such a circuit is normally made variable, so it's not fixed, okay, you can keep on varying, and connected to the tuning control, so that the receiver can select any desired transmission with a predetermined range. For example, for a typical FM communication system, FM system, frequency modulated system, the frequency range is 88 megahertz to 108 megahertz. There are many channels, okay, Radio Mirchi, then Suryan FM. There are many things in Tamil Nadu, I don't know in other states. So each channel can be tuned, and that particular desired frequency is passed to the receiver, and rest of the frequencies are rejected. So that can be done with the tuning circuit, that is variable. Okay, so the use of modulation process helps in shifting the given message signal frequencies to a very high frequency range. See here, very high frequency range in the sense where it can occupy only negligible percentage of the spectrum. For instance, at 100 or let's say 1000 kilohertz, the 10 kilohertz wide message signal represents 1% of the spectrum. Let's say you have a message signal m of t, its spectrum is like this. Maybe I will draw the figure. It's not exactly like this, it is just a representative figure. Let me say this is my message m of omega, and from positive side 10 kilohertz and negative side minus 10 kilohertz. I will tell you what we mean by negative frequencies. Once you do the modulation, then what it goes is it sits on the 1000 kilohertz, and it sits like this. So this is going to be 1010 kilohertz, and this is going to be 990 kilohertz. So the total width is 20 kilohertz. So that's how you are shifting the frequency, the same frequency, same spectrum, the spectrum which ranges from 0 to 10 kilohertz. Now it is from 1000 kilohertz to 1010 kilohertz. Okay, so therefore if you look at here, this total occupancy will be 1% of 1000 kilohertz. But if you look at 1 megahertz, 1 mega, or let's say 1 gigahertz, then again the spectrum occupies very less portion. Okay, 1 gigahertz plus 1 gigahertz plus 10 kilohertz, this point is, and this point is 1 gigahertz minus 10 kilohertz. You can now substitute the value. 1 giga means 10 power 6 and kilohertz means 10 power 3. Sorry, gigahertz means 10 power 9. I am sorry. Mega means 10 power 6. So in this case, at 1 gigahertz frequency range, the spectrum occupancy will be 0.001%. This means that more number of message signals can be accommodated at higher frequencies. See, I can put hundreds of messages at 1 gigahertz. Okay, so I put one more 10 kilohertz, one more 10 kilohertz, one more 10 kilohertz, like that. I can put many number of message signals, so which can be accommodated at higher frequencies. So this is a typical advantage when you do the modulation. Okay, although the separation of signals has removed a number of difficulties encountered in the absence of modulation, the fact still remains that unmodulated carriers of various frequencies cannot by themselves be used to transmit information. Suppose you have a carrier and if you don't do any modulation, then you cannot transmit. What is the use? After all, the carrier is a sinusoidal waves, pure sine waves, and it is a complex constant sine wave. The amplitude is constant. What is the use of transmitting this without modulation? Even if you transmit the sine wave, there is no use. What is the use of transmitting a sine wave from one place to another place? Okay, so therefore unmodulated carrier has a constant amplitude and a constant frequency. See, the amplitude is constant and the frequency also constant, or phase also constant. Okay, with respect to some reference. Therefore a message consists of ever varying quantities which can change the either amplitude or frequency. For example, for a speech, for instance, is made up of rapid and unpredictable variations in amplitude. You cannot predict actually. Okay, variations in amplitude. When I say amplitude, it is a technical term in electrical engineering. The layman language is volume. So if you go and say amplitude, he may not understand. If you say volume, increase the volume or decrease the volume, then he will understand. Okay, so there is a volume. So amplitude or volume. And frequency also rapid and unpredictable. This also rapid, because frequency continuously changes if you take a voice. Also unpredictable. So the frequency is also called pitch, and sometimes people say resonances. So since it is impossible to represent these two variables by a set of three constant parameters. Okay, so what are the three constant parameters? Amplitude, frequency and phase. Amplitude, frequency and phase. These three are constant parameters in a pure sine wave. But here in unpredictable manner, the amplitude is changing and frequency also changing in the message. Somehow I need to connect this guy and that guy. Okay, so what I will do is at a in a continuous wave modulation, like amplitude or frequency modulation, but not the pulse modulation. Anyway, that I will come to that little later. One of the parameters of the carrier is varied by the message. You take the message and vary any one parameter. Either you change the amplitude with respect to the message, or change the frequency with respect to the message, or change the phase of the carrier with respect to the message. With respect to message means with respect to amplitude or with respect to frequency, because in message I have two attributes now. One is amplitude and another one is frequency. So are you going to change the amplitude of the carrier with respect to amplitude of the message or with respect to frequency of the message? Are you going to change the frequency of the carrier with respect to amplitude or with respect to frequency of the message? Are you going to change the phase of the carrier with respect to amplitude of the message or with respect to frequency of the message? So that's what one need to understand in this one. Okay, so therefore at any instant it's deviation from the unmodulated value, either amplitude or frequency, is proportional to the instantaneous amplitude of the modulating voltage or modulating signal. So in the modulating signal we will not consider frequency. What we consider is amplitude. So the amplitude of the message signal controls any one parameter. It controls amplitude of the carrier. Let me give the definition formally little later, but now just in layman language I am explaining this. Amplitude of the carrier, or it may control frequency of the carrier, or it may control phase of the carrier. If the amplitude of the carrier is changed with respect to the amplitude of the message signal, then it is called amplitude modulation. If the frequency of the carrier is changed in accordance with the amplitude of the message signal, then this is called frequency modulation. If we change the phase of the carrier in accordance with the amplitude of the message signal, then it is called phase modulation. So predominantly we have three types of modulation in analog communication system: amplitude modulation, frequency modulation and phase modulation. So in this fashion, enough information about the instantaneous amplitude and frequency is transmitted to enable the receiver to recreate the original message. Okay, so let me summarize this lecture. So the need for modulation is, first one is ease of radiation. So easily you can radiate. Then the second point is frequency translation to different frequency bands, so that you can occupy or transmit simultaneously many message signals from different users. So this process is called multiplexing. Okay. For example, let's say mic 1, here let's say X is speaking and Y is speaking on mic 2 and Z is speaking on mic 3. Then this signal contains, let's say, 0 to 4 kilohertz. This also contains 0 to 4 kilohertz. For telephone communication I am talking about now. Now if you combine these three guys together through a common channel, the channel can be, let's say, coaxial cable or something else. Then what will happen, these three will mix each other and you cannot separate out. So what you do is put a modulator here and the frequency is 550 kilohertz and give it to here, and here put a modulator and here 555 kilohertz. You put another modulator here 560 kilohertz. So this guy is from mic 3, whatever the output is coming, which is in the frequency spectrum from 0 to 4, and that is modulated with the 560 kilohertz. Anyway, 560 will not interfere with 550. You put everything given to the multiplexer and give like this and transmit through the common channel. So that is possible if you do the modulation process. Otherwise you cannot transmit. Whenever you have a common channel, then you cannot transmit many signals. So for that purpose we need to go for modulation. And the third point is to avoid bands with noise and interferences, because certain frequency bands are highly noisy or there is a lot of interference in those frequency bands. Okay, so that's all about the need for modulation. Probably in the next lecture let me talk about electromagnetic spectrum and typical applications. What are the different spectrum that we have, and what are the typical applications, like at what frequency band the mobile phone communicates, and at what frequency range your TV signal is transmitted, and at what frequency range your FM signal is transmitted, and what is the frequency range over your telephone system operates. These are the things that we will discuss in the next lecture. Thank you very much.